All right, so this is going to be part 3 of 4 of the extra math from SAT 9. I'll just pull the link up again. This is the test I'm working from. Let's get back into it. So this is page 3, number 21. So exponential function has a y-intercept of d, so x equals 0. We get d, so already I'm going to look through my answers for that. That gets rid of d, that gets 0, that is out front, and then I glance at this one, and that's perfect. Just a little reminder that when we raise to the power of 0, our number turns to 1, so that's just going to be d times 1. 3 to the 0 is going to be 1, right? So d for this one. Not too bad, just like little niche problems I come across that feel maybe a little bit less standardized, so it's good to practice these. Number 23, another statistics one. I think these are great to practice because they can be kind of odd in their wording. So this one, I'm just skimming through. 28% responded yes, 70% responded no. Which of the following best explains why the results are unlikely to represent? So maybe we skip something in the beginning. A U.S. cable news show. The host invited guests to respond. Okay. So they're asking, why would this maybe be unlikely to represent the country, right? These statistics problems, we're always looking for that same word, bias. Okay? Doesn't add up to 100. That just means some people decline to answer. That doesn't mean anything. Oh, what's that? Respond to the poll were not a random sample of the population. They were specifically people on this show that could have been leaning a certain way, right? So I already know that's the right answer. But let me look at the other ones. 50% yes, 50% no. That doesn't make any sense. The show did not allow viewers enough time to respond. They didn't give any context to that. It's always going to be answers like B. What was the biased, right? What represented this problem to be not a random sample? And that's B. Perfect. Number 24 here. Okay, take a look at this for a second. What do you think? So what I kind of see as my inclination is I see a change happening here, right? I see a change specifically from this to this. And I try to think, so it went from being x to x plus a, and then I went from this to this. So whatever they did to my x, say it was 5 and they added 2, it's completely manipulated the rest of my equation, right? So I already have an equation of f of x plus a equals that. What could I maybe categorize this? We could maybe compare it to the mirror problem of I have 2 equations and I want to be able to compare them. As of right now, I can't because one equation is f of x, one is f of x plus a. Well, what if I fix that? What if I make one of them equal the other one? And it'd be really hard to make this f of x because I don't know what a is. But couldn't I make this equation f of x plus a? Let's do it. So if I go over to that equation and I say f of x plus a, and I say that's equal to 5x plus a squared minus 3. This should get me f of x plus a, and since this is also f of x plus a, I should be able to set them equal, right? So I just like to add in my little x plus a here, save me a little bit of time, so that's going to be 5x squared plus 2ax plus a squared. And then for the finale here, 5x squared plus 10ax plus 5a squared, and then minus 3. Perfect. So I have both my equations now. These should be, again, a 1-to-1 comparison. I see this is the problem I was maybe inferring to in an earlier problem, or alluding to, is this is the one where my x squareds actually line up, right? So it looks like I could compare my x terms, and then my, I actually underlined too much here. So this is another good reminder. This is my x term. This would be my c term, right? So my 30 is actually equal to 10a because a is a constant. So that's why 42 is going to equal that guy. So 10a is equal to 30, I know that a is going to be equal to 3 here. So again, another example of, this one's kind of more on its own. You don't really see versions of this too much, but it kind of turns into a mere problem. But they could always trip you up with that, oh, f of x plus a. So always try to develop these inclinations of, when I see a problem like this, this is the direction that I go, right? So it's going to be C for this one. Yeah. 24C, yeah. And then over here, this is another good reminder. This is going to be a little triangle problem, even if you don't notice it right away. So I have sine of x equals a. Which of the following must be true? So I'm already just going to glance at one of these, and that is, let's try to maybe give a really good example of which one I want to glance at, right? And we just want to think of a standard right triangle. So if I have, 3, 4, 5, and I have an angle that I wanted to analyze, and I said, okay, say this angle is A, and I look at sine of A, right? Sine of A is going to be, I do my SOHCAHTOA, is going to be 4 over 5, right? And I think, okay, what if I did, this is B, and I did cosine of B? Cosine of B is going to be, who would have guessed, 4 over 5. So what happens is there is a relationship between complementary angles. So if A was 30, this would have to be 60, right? Etc. I could come up with any combo. These angles are complementary, and it turns out that complementary angles, when you take the sine of one, the cosine of the other, they are going to be equal to each other. So you'll see problems like 25. They'll try to mask it in different ways. I think this is a little bit more of a confusing way to mask it. So I'm looking for sine of x is A. I'm looking for cosine of 90 minus x, because that would be my complementary angle, right? There it is. Cosine of 90 minus x is also equal to A. And if that still seems a little confusing to you, try to plug these numbers into my triangle, right? Say my x is 30. Then 90 minus 30 would be 60. And then we can directly apply them to our triangle here. It would be sine of my 30 is 4/5. Cosine of my 60 is 4/5, right? So a really good, and I forgot I haven't emphasized this yet in my videos. Make note cards of everything. I promise you, the #1 way to study for these tests, where there are so many little roles, so many little ways to solve these problems, make note cards of everything. And what you could do is you could even compile them. You could say, oh, here are 2 or 3 or 4 examples of a mere problem, and here's how they look. Here is a role for complementary angles, sine of x, cosine of 90 minus x. All these problems I would have a big stack of note cards for, because that's the easiest way to kind of memorize them, you know? A couple more problems here. What about 26? So I think this is just a good one. If you took physics, you're probably super familiar with this one. Negative 16x squared, etc., quadratic. It models the height of a projectile x seconds after its launch. So it's going to be something that probably starts like this and falls down, because the other side's going to be kind of hidden by the y-axis. So, and I already can start to tell you, just by looking at my graph, I can tell you that, it's going to be downward. We're starting at 10, so on my x equals 0, this guy up here is going to be 10. If we needed to, we could find other stuff from the, negative b over 2x. So they say, which of the following represents the real-life meaning of the positive x-intercept of the graph? Okay, so it looks like they're looking for this, right? So we're dealing in terms of x, and they already told me that x is seconds. So the reason why they're not talking about this is because that's going to be, contextually, it's not going to make sense that we have negative seconds. But the positive one is going to be, just for my graph, how many seconds it took for our object to hit the ground, right? So these physics ones, even if they're on the easier side, they're really good to review. I look at D down below, but let's look at the other answers just in case. The initial height, that's going to be the 10, which we've already established. The maximum height, I guess that's going to depend on if the vertex is before the y-axis or after the y-axis. But that would be my vertex. We would be looking for the y of my vertex here. And the time at which the projectile reaches its maximum height, that's also the vertex, right? That would be my x of my vertex, because that would be kind of half. Usually it's like a halfway if they show the full parabola. But yeah, all things that I think we could solve for, especially using Desmos. And the final question for this page, let's move my camera over here. So this one is a little confusing. I might have to zoom out so you can see all the different answers. Let's maybe like that, and maybe a little bit more. Let's see if we can see this. Okay. Maybe a tiny bit less. All right, perfect. So number 29 here. Let's get rid of this clutter on the left here. So most graph problems are on the easier side. This one, they really dig into the context. They really try to make it as confusing as possible. So take a shot at it for a second. You can pause it. So I want to be very familiar with my axes, right? My x-axis, it looks like they're labeling it by tens. Okay? And I see a graph here. Let's highlight that graph. Y-intercept of negative 0.488. And line of best fit. What does the line of best fit predict about the increase in minimum wage over the 70 years? So the increase over 70 years. So I know they're not dealing with my y-intercept, right? So anything I see about 0.488, wrong. And another one, 0.49. I know that one is not associated with my increase. My increase over time is going to be the 0.096. But it looks like they're challenging us with context here. So A is saying each year in this 70-year period, the increase was $0.096. C is saying every 10 years, the average increase is. So unless you're a contextual master, this one could be pretty confusing. So I could just kind of glance at it, right? I could say at year 10, it looks like we're at about 50 cents. And year 20, we're at about $1.50. So if I round this guy up, it looks like that's only about 10 cents, right? The 9 rounds up to about 10 cents. So if C was correct, that's 10 cents every 10 years. Well, no, it looks like it's $1 every 10 years. So it would have to be 10 cents every year for it to be $1 every 10 years, right? So this one, challenge the contextual problems with math, with numbers. Plug some numbers in, because that's going to make a lot more sense than trying to dig into the words, you know? So perfect. That's going to be the third page. Awesome.